Girls, I am Shamsunisa from Royal Degree College, Chemistry Department. In Unit 2nd, Organic Chemistry, Chapter 1, Amines, Cyanides and Isocyanides. Today we'll see electrophilic substitution of aromatic amine, preparation of diazonium salt, replacement of diazonium group by OH, chlorine or bromine, fluorine, iodine, cyano group and hydrogen. Coupling reaction with phenol and aniline. First of all, we'll see about electrophilic substitution of aromatic amine. In this, we are talking about the two reactions. One is bromination reaction and another one is nitration reaction. So here the electrophile is bromine. Bromination is addition of bromine. So electrophile is bromine over here. And in case of nitration, nitro group is acting as an electrophile. So we'll see first about bromination. Due to greater activation caused by NH2 group, the treatment with bromine forms a symmetrical tri-substituted product with bromine water. Aniline gives a white precipitate of 2,4,6 tribromoaniline. See the reaction. We are taking aniline to the benzene ring, NH2 is attached. See on the benzene ring at the two ortho positions, one side here, another ortho position and one para position. Hydrogen atoms will be there. Those hydrogen atoms are going to be replaced by bromine, substituted by bromine. So we are taking the 3-bromine and the reaction will take place in the presence of bromine water. So we are getting this product, that is 2,4,6 means at the second position of benzene ring Br is attached, and at the fourth position Br is attached, and at the sixth position Br is attached. To whom? The aniline. So it is named as 2,4,6 tribromoaniline. And the hydrogen atoms from the ortho positions and para positions which are coming out reacting with 3 more bromine, and we are getting the side product 3 moles of hydrogen bromide. If NH2 group is protected by acylation before treatment with bromine, only para product present. The para-bromoacetylide on hydrolysis gives para-bromoaniline. See the reaction. We are taking aniline. In that we are adding acetic anhydride, that is CH3CO taken twice O. Reaction will take place in the presence of pyridine. So what will happen? From aniline, one hydrogen it is coming out. In place of that one, from acetic anhydride, COCH3 is attached there. And it is named as acetanilide. Okay, it is named as acetanilide, which is also named as N-phenyl ethanamide. And we are getting here one side product also, that is CH3COOH. Then this acetanilide, in that we are adding bromine. So in the acetanilide, at the para position of the benzene ring, one hydrogen atom will be there. That hydrogen atom it is substituted with bromine, and we are getting this main product, major product we are getting this. Okay. To the benzene ring at the para position, Br is attached. At the under para position, NH, C double bond O, CH3 is attached. In this, we are adding water molecule. Okay, we are adding water molecule. So, what will happen here? This group, CH3CO is coming out. In place of that one hydrogen from water molecule is substituted here. So, we are getting this product, that is benzene ring NH2 is attached, and at the para position, Br is attached. So it is named as 4-bromoaniline. And our side product will also be there here, CH3COOH. That is the acetic acid is our side product. Next reaction we will see, that is named as nitration. We are taking aniline here. In this we are adding acetic anhydride, CH3 C double bond O, O single bond, CH C double bond O, CH3. Okay. So then what will happen from aniline? One hydrogen is coming out. In place of that one, from this side, COCH3 is attached. Okay, it is named as acetanilide. One hydrogen which is coming out from aniline reacting with this CH3COO, and we are getting CH3COOH, acetic acid. Then in the next step, we are taking acetanilide. Okay, in the acetanilide, we are adding fuming sulfuric acid and fuming nitric acid. So nitric acid is taking part in the reaction and sulfuric acid is acting as a dehydrating agent. Here, first of all, from the ortho position of the benzene ring of acetanilide, one hydrogen atom is coming out. In place of that hydrogen atom, NO2 group from nitric acid, NO2 group is substituted here at the ortho position. So we are getting here benzene ring, single bond NO2, then single bond NHCOCH3. It is known as orthonitroacetanilide. And one side product also we'll get here, that is one hydrogen which is coming out from ortho position reacting with OH of the nitric acid, and we are getting the side product what? Then one more product we will get, that will be the major product. At the para position of the acetanilide, one hydrogen atom is substituted with the NO2 of the nitric acid. Okay, so we are getting here para nitroacetanilide. Here also we'll get one side product, that is this side product here we'll get water molecule. One hydrogen from the para position coming out reacting with OH of the nitric acid, and we'll get the side product water. Then in the next step, we are taking para-nitroacetanilide, which is our major product. In that, we are adding 70% sulfuric acid and 10% sodium hydroxide. Here, the hydrolysis reaction will take place. So, what will happen here from this acetanilide group? That is NHCOCH3 is there, na? COCH3 is coming out, reacting with hydrogen of water molecule. And means in place of COCH3, hydrogen from water molecule is substituted here, and we are getting NH2. Okay, and this group CH3CO is coming out now, reacting with OH of the water molecule, and we are getting here the side product water. And our main product is para nitroaniline. Next we will see about the preparation of diazonium salt. How to prepare the diazonium salt, that we will see. Treating aniline with nitrous acid, which we are getting from sodium nitrite and cold dilute hydrochloric acid at 0 to 5 degrees centigrade, gives benzene diazonium chloride. See the reaction here, as we are taking aniline, in that we are adding NaNO2, that is named as sodium nitrite, and 2 moles of hydrochloric acid. The reaction will take place at the temperature 0 to 4 or 0 to 5 degrees centigrade. Then what will happen here, from the aniline, 2 hydrogen atoms are coming out. Okay, in place of that one, from sodium nitrite, one nitrogen is substituted here. So we are writing here benzene ring and N2 plus. Okay, and one Cl from hydrochloric acid is being attached with the N2 plus, and we are getting Cl minus. So it is named as diazonium salt, which is also called benzene diazonium chloride. Okay, then in the sodium nitrite, Na is there. Na, it is reacting with one more Cl, and we are getting the side product NaCl. Another side product we are getting here as 2 water molecules. See the next reaction, we are taking aniline C6H5NH2. Okay, in that we are adding HCl. We are getting here addition product, that is C6H5NH2 HCl. It is named as aniline hydrochloride. In the next step, we are taking sodium nitrite NaNO2. In that we are adding HCl. So what will happen? Na will react with the Cl, and we are getting sodium chloride. Then this hydrogen of HCl reacting with NO2, and we are getting HNO2. It is named as nitrous acid. As we are getting here the nitrous acid, that nitrous acid we are taking in the next step in the expanded form. We are writing here HONO. Okay, to which we are adding C6H5NH3 plus Cl minus, which is nothing but aniline hydrochloride. Okay, The reaction will take place at the temperature range of 0 to 5 degrees centigrade. Then what we will get here? See, C6H5N will be there. This H3 is coming out. In place of that one nitrogen from nitrous acid is being substituted here. So we are getting C6H5N2 plus, then Cl minus as it is. It is named as benzene diazonium chloride. Along with that, we are getting the 2 moles of water. This process of preparing a diazonium salt is called diazotization. Here we'll see the mechanics of diazotization. Okay. So in this, first of all, we are taking nitrous acid, that is has single bond O on oxygen, lone pair of electrons. The 2 lone pair of electrons are there. Then single bond nitrogen, on nitrogen 1 lone pair of electron, then double bond O. In that we are adding H plus. So what will happen? This H plus, it is forming a bond with the oxygen. As on the oxygen lone pair of electron is there. Now this lone pair of electron sharing and pairing and forming a bond with the hydrogen. This product we are getting. Okay, on reversible equation, and oxygen will carry the positive charge. Now on reversible equation, what will happen? A bond which is present in between oxygen and nitrogen, that bond it is shifted towards the oxygen. So H2O is coming out. See here, H2O is coming out. Water molecule. So on nitrogen, as this bond is going now, so nitrogen is becoming electron deficient. So we are getting nitrogen, lone pair of electron with electron deficiency, the positive charge, then double bond O. It is named as what? Nitrosonium ion we are getting. Now here, nitrosonium ion we are getting here. So next part of the mechanism we'll see, that is formation of diazonium ion from aromatic amine. How we are getting? Here in the step 1, what we are doing? Addition of nitrosonium ion to the aniline. Okay, nitrosonium ion, it is being added to the aniline. We are taking aniline, benzene ring, NH2, and on nitrogen lone pair of electron will be there. Now that lone pair of electrons, it is forming a bond with the nitrosonium ion of nitrogen. Okay, so like this we are representing. And what will happen in between nitrogen and oxygen? A triple bond will be there. Now, so double bond remains. One of the bond it is shifted towards the oxygen. So we are representing here what? Here we are representing the 2 lone pair of electrons on oxygen, on nitrogen 1 lone pair as it is. Then in between this nitrogen and this nitrogen, bond is going to be formed, and on this nitrogen electron deficiency will be there, isn't it? Then Cl minus. Here how the Cl minus? Here you can see this Cl minus is there, isn't it? This Cl minus we are representing as it is. Then from this, what will happen here? Second step is the proton transfer. How the proton is being transferred? It is getting transferred. That we will see. Here NH2 will be there, isn't it? One of the hydrogen, that is nothing but the proton, it is going to attach with the oxygen. Okay, it is going to attach with the oxygen. One lone pair of electron is there, na, sharing and pairing and forming a bond with the hydrogen. So we are getting this product. Okay. Then in the next step, we are getting the resonating step. Resonating step means how we are getting this resonating step. One double, see here, in between nitrogen and oxygen double bond is there. Now one of the bond, it is shifted towards the oxygen. So here we are representing a lone pair of electron on the oxygen. Here, lone pair of electron on the oxygen. Then at the same time, here on the nitrogen, lone pair of electron is there, na, sharing and pairing and forming a bond in between the 2 nitrogen atoms. So here the double bond is created in between the 2 nitrogen atoms. So this nitrogen atom, it is becoming electron deficient, so it will carry the positive charge. Rest of the things are as it is. Then from this, what will happen again in the third step? The proton transfer will take place. How the proton is being transferred, is getting transferred. Means, see here, in the previous case, one hydrogen which is attached with the nitrogen, that hydrogen, it is coming out from that side and going to attach to this oxygen. Okay. So we are getting this structure. We are getting this structure. So one lone pair of electron, it is along with that nitrogen. Means hydrogen is coming out from this side by leaving the bond here itself with that nitrogen. So because of that reason, lone pair we are representing on the nitrogen, and that hydrogen is going to attach with the oxygen, and here on the oxygen a lone pair of electron is then sharing and pairing and forming a bond with the hydrogen. Rest of the things are as it is. Then in the next step, elimination of water. How the water is being eliminated. See here, in between nitrogen and oxygen, a bond is there. Now that bond it is shifted towards the oxygen. So H2O is coming out. H2O it is coming out. Then here at the same time, lone pair of electron is there on the nitrogen. It is sharing and pairing and forming a one more bond in between these two nitrogen atoms. So how many bonds is going to be created in between the nitrogen and nitrogen? Triple bond. So here we are representing like this. See, benzene ring, single bond end, then triple bond end. On that nitrogen, lone pair of electron. On the previous nitrogen, electron deficiency will be created, the positive charge, then Cl minus. So it is nothing but diazonium salt, which is named as benzene diazonium chloride. Next we will see about replacement of diazonium group by OH. An aqueous solution of benzene diazonium chloride on heating yields phenol. So see here, we are taking benzene diazonium chloride, benzene ring to which N2 plus is attached, N2 is di, the 2 is di, nitrogen is azo, okay, diazonium, Cl is chloride, diazonium chloride. In that we are adding water molecule, we are providing heat, it is to be warm. Then what will happen here, from the benzene ring, N2 group, this N2, it is coming out as a nitrogen gas. And this Cl is coming out reacting with hydrogen of water molecule, and we are getting the Cl, and OH remains in the water. So OH is going to attach to the benzene ring. So to the benzene ring OH is attached, so it is named as phenol. Next, replacement of diazonium group by chlorine or bromine. That we will see. When the aqueous solution of benzene diazonium chloride is heated with cuprous chloride CuCl or cuprous bromide CuBr, we get chlorobenzene or bromobenzene. The reaction is catalyzed by cuprous ion. It is called Sand-Miller's reaction. So we will see the reaction here. We are taking benzene diazonium chloride. Okay. In that we are adding CuCl and HCl. Then here what will happen? This N2 it is coming out. We are getting the side product as nitrogen gas, and this Cl it is going to attach with the benzene and we are getting here chlorobenzene. Next is benzene diazonium chloride. In that we are adding copper and hydrochloric acid. Okay, hydrochloric acid. So what will happen here? This N2 from the benzene diazonium chloride coming out as a nitrogen gas. Then this Cl, see here, this Cl reacting with this H. Cl is reacting with this H. We are getting one more side product, that is hydrochloric acid. And this Cl which is present in the hydrochloric acid, it is going to attach to the benzene. And we are getting the chlorobenzene. Next is benzene diazonium chloride. In that if you are adding copper and hydrogen bromide, then what will happen here? This N2 group it is coming out as a nitrogen gas. Then this Cl reacting with Cu, okay, and we are getting CuCl. Then what will happen? This Br is remaining here. This Br is going to attach to the benzene ring and we are getting bromobenzene. And this hydrogen is also coming out as H+. So in place of cuprous salt, if copper powder is used, the reaction is called Guttermann's reaction. Now we'll see about the replacement of diazonium group by fluorine. Fluorobenzene is prepared by adding diazonium salt solution to fluoroboric acid The fluoroborate gets precipitated. It is washed, dried and heated to get fluorobenzene. The reaction is called Schimann reaction. You can see the reaction here. We are taking benzene disonium chloride. In that we are adding HBF4, that is known as fluoroboric acid. Then what will happen here? This group, this hydrogen from the fluoroboric acid reacting with the Cl, and we are getting the side product HCl. And in place of Cl, BF4 is going to attach to it, and we are getting this intermediate compound, that is benzene ring N2 plus BF4 minus. Okay, it is known as benzene disonium fluoroborate, to which we are providing heat. If you are heating that, so what will happen here? N2 solid, it is coming out as a nitrogen gas. BF3 will come out, boron trifluoride. Okay, and one fluorine remain, that is going to attach with the benzene. So we are getting here fluorobenzene. Then next is the replacement of disonium group by iodine. Iodobenzene results. How? By heating aqueous disonium salt solution with potassium iodide. We are taking here benzene disonium chloride, to which we are adding potassium iodide and providing heat. So what will happen here? This N2 group, it is coming out from benzene disonium chloride as a nitrogen gas, and Cl is coming out from this side reacting with potassium of potassium iodide, and we are getting the side product potassium chloride. Okay, and in place of N2 plus Cl minus, iodine is substituted, so we are getting iodobenzene. Replacement of disonium group by cyano group. Cyano group is CN. CN group is considered to be as the cyano. Benzene disonium chloride, when heated with cuprous cyanide, it forms cyanobenzene. This reaction is called Sand-Miller's reaction. See here, we are taking benzene disonium chloride. Okay, in that we are adding CuCl, which is named as cuprous cyanide, and the reaction will take place in the presence of potassium cyanide. So what will happen here? This N2 group from the benzene disonium chloride, it is coming out as a nitrogen gas. Okay, then this Cl, it is coming out reacting with Cu, and one more side product will get, that is CuCl, and in place of N2 plus Cl minus, Cn is substituted. So benzene ring single bond Cl, it is named as cyanobenzene. Next is replacement of disonium group by hydrogen. With hypophosphorus acid, that is H3PO2, in presence of Cu2Cl2, it gets reduced to a hydrocarbon. So here we'll see this reaction. Benzene disonium chloride we are taking, in that we are adding two nascent hydrogen. Reaction will take place in the presence of H3PO2. Okay, so what will happen here? This group N2 group, it is coming out as a nitrogen gas. Okay, then one hydrogen from this side reacting with the Cl, and we are getting the side product HCl. Then one hydrogen remain, that is attached in place of the N2 plus Cl minus. It is substituted here, and we are getting the benzene. Next is coupling reaction with phenol. Benzene disonium chloride react with aromatic ring of phenol in presence of sodium hydroxide to form para-hydroxyazobenzene. Such reaction is called coupling reaction. Look at this reaction, girls. Benzene disonium chloride. This is the structure of benzene disonium chloride. Okay. In that we are adding what? Phenol. So here at the para position, one hydrogen we are representing outside the benzene ring. Then here what will happen when the reaction between benzene disonium chloride and phenol will take place? This reaction is taking place in weakly alkaline solution, that is pH range is here 9 to 10. Then what will happen here? This Cl of benzene diazonium chloride coming out, reacting with hydrogen of phenol, and we are getting the side product HCl. Okay. Then what is remaining there? Benzene ring, single bond, and here double bond will be there. Okay, double bond will be there. One of the bond it is shifted towards this side, and to which this whole group, the phenol group, is going to attach. That is benzene ring, single bond only. So it is named as 4-hydroxyazobenzene, which is nothing but orange dye. Coupling reaction with aniline. So here in this, benzene diazonium chloride react with aniline in presence of sodium acetate to form para-aminoazobenzene. See here the reaction. We are taking benzene diazonium chloride. In that we are adding phenol. Reaction will take place in the presence of base OH minus. So what will happen here in the benzene diazonium chloride? From that, once this Cl is coming out, reacting with hydrogen of aniline, and we are getting what we will get here, HCl will come out. Okay, one hydrogen from this side and one Cl. Then again, what is going to be happening here? Hydrogen, it is reacting with OH minus, and we are getting the side product water. And Cl minus, the chloride ion, will be as it is. Then to this particular group, that is benzene ring, single bond, and here the double bond will remain. Then now with the double bond, nitrogen is attached, and one of the bond it is coming outside, and it is being attached with the aniline. Okay, benzene ring and H2. So we are getting this particular product, which is named as para-aminoazobenzene. See here, at the para position, amino group is attached. Okay, this is azo, the two nitrogen, azo. Okay, these are the benzene. So para-aminoazobenzene we are getting. This is yellow dye. Thank you for listening my lecture, girls.